Ok, bonjour et bienvenue. Excusez-moi pour mon français. Je suis né à Montréal, mais mes parents sont anglais. Et j'ai habité à Vancouver la plupart de ma vie. Donc, je parle anglais. Well, so hopefully this session won't be quite that painful. So I'd like to share with you a few tips about agile modeling. I've been applying what today is called agile modeling since the 1980s for close to 20 years, long before it was called that. I used to just call it hands-on modeling. And as I think you know, I serve as chief scientist for Valtech. And if you want to get a copy of this presentation or contact me, my website is craiglarman.com. And in the context relevant to this presentation, I'm the author of a book called Applying UML and Patterns, which I'm grateful to report is the world's best-selling book on UML and OO analysis and design, and is the standard text worldwide in universities for an introduction to software design now. I think it's in 15 languages. It's literally the standard university text throughout the world. And I've been working in modeling and the UML for many, many years, and I love to do modeling. But as the book, The Java 2 Performance and Idiom Guide, illustrates, I work as a hands-on programmer. I'm an experienced Java, C++, Smalltalk, COBOL, Fortran, C, C# developer. I know how to cut code, and I do it all the time. And one of the most important first things that I try to share with people is that the only good modeler is a master programmer. I sometimes meet people who are like armchair modelers or philosophical modelers who actually aren't master programmers, and therefore the models they create are crap. You know, they give them to somebody else in a kind of handoff model, this idea that's associated with the waterfall of a architect or a designer creating models and then giving them to someone else to program. Of course, this is a waterfall idea and the very worst way to do modeling. Good modeling is done by a master programmer for himself or herself with colleagues who are also master programmers. Anything that smells like the waterfall, where a person creates diagrams or models and then gives them to someone else to implement, which is a waterfall idea, is a worst practice and completely inconsistent with modern software practices and agile modeling and agile methods. We model for ourselves as a programmer. A programmer does modeling for himself before he himself programs, not to give to anyone else. This is a key point of successful modeling and design. Some resources. There's the website Agile Modeling, managed by Scott Ambler, who is actually a fellow Canadian who lives not too far away from where I live in the countryside of Ontario. My website has some materials, and Martin Fowler, another expert in modeling, also has some resources. This is the single most important thing. The single most important thing of what it means to do successful modeling, which is to model on giant whiteboard spaces. Some people get the mistaken impression that good UML or modeling has something to do with case tools or UML software tools. Absolutely false. As you can see, this is one of my teams. This is one of my teams in Miami. I've actually just come from there. And this is their development room. And of course, they're applying the modern agile practice, which is really valuable for software development, that at the sub-team level, a sub-team has a common room. They don't work in separate offices. They don't work in separate cubes. They work in a common space, and the walls are all surrounded with whiteboard material. This team went to a office supply store, and they got these 4 foot by 8 feet sheets of very cheap whiteboard material. I think it was $20 or about 17 euros per sheet, and then they've actually covered every square meter of the room with this whiteboard material. And they're holding a modeling day in which they're spending the whole day sketching UML diagrams at the whiteboard and collaborating and looking at each other's work. So one of the key ideas of modeling is to work in giant visual spaces. If you think about it, the natural human environment for drawing is not a little tiny computer screen. It's a giant visual space. The UML, the Unified Modeling Language, the definition of the UML is that it's a visual, this is the definition, a quote from the preface, it's a visual modeling language. The key word there is visual. It's supposed to play to the strength of us as humans, which is diagrams, boxes and arrows, connecting blobs on a big visual space with lines. Humans are very good at understanding information that's represented like that. And if you think about your body and your eyes, like imagine you're half a meter away from a wall. What is your natural human visual space? It's, easily 3 meters by 2 meters or 4 meters by 2 meters. That's your natural visual space. And what is the natural way for a human to draw? It's with something in their hand, like a pen. What we want to do in modeling is get rid of hard-to-use tools. We want to stop using tools which inhibit creativity. We want to stop using tools which inhibit flow, as it's called in psychology, creative flow. And instead we want to use very simple tools that don't get in the way and which encourage creative flow, which typically means giant whiteboard spaces, markers, and so forth. And in terms of process, the usual way to do good modeling is that each iteration, for example, 3-week time-boxed iteration, when I'm coaching a team, will start day 1, Monday of a 3-week iteration, without any work at the computers. And everyone on this day that is normally called modeling day, everyone during modeling day will spend their time at the whiteboards, usually in small groups, and doing modeling related to the design and architecture and UI work and database work to support that iteration. The teams will visit each other's walls. So, for example, I remember some people down there at the far end during this modeling day, they were spending half an hour doing some work on their wall, and then they went down to the far wall where that guy by the wall and these two guys at the computers there, they were just for a couple of minutes looking at some software, and then they went back to their wall and they were sketching a diagram. And then these gentlemen at this end would go down there, look at their work, review it, and then come to a common understanding and a real-time review that improves the quality of the design. And you'll notice there isn't any UML case tool in here at all. I don't know if, so I'm, the most widely used author and consultant in the world for the UML, and I virtually never use a UML case tool. Martin Fowler, the second most popular author and consultant for UML, never, ever uses a case tool. Grady Booch, one of the creators of the UML, who I've known for many years, this is how he typically does modeling. He doesn't use rational rows and so on and so forth. The idea that case tools are what you need to use for UML. This is an idea created by salespeople. It's not an idea actually created or supported by expert modelers. It's a kind of academic idea. Don't misunderstand me. It's not that there's no place for software case tools. They have a very narrow, minor usefulness. But in general, for creative design work, they're not especially useful today in 2006. Perhaps in 5 or 10 years, when I can use a so-called computer tool, which allows me to draw on a wall with a marker, and everything is immediately captured by a computer, and I essentially have a human-computer interface which is usable, which supports the natural visual space of a human, then I have no problem using a computer tool. But when we're talking about drawing and visual languages and symbology, and that's what we're talking about when we're doing modeling with the UML, then this little tiny, 10-inch by 20-inch computer screen and using a mouse and being inhibited for creative discovery by the incredibly bad usability and being inhibited from having 3 or 4 people at the same time talk about and share creatively how to do a design. Given those limitations of today's tools, then I have a real serious problem with using a UML computer tool for creative discovery and design. This is an example of a model. This is actually a sketch that this team was doing at the wall down there at the end. It's a UML deployment diagram. And I remember a person from the other end coming down and saying, "Oh, you forgot one of those servers," and then they sketched it in. And so by the ability of 3 people doing it together at a giant whiteboard space, those 3 people come to have a deep common understanding of, in this case, the physical architecture. And because it makes it easy for other people to walk down to this end of the wall and look at it and review it in real time, the other team gets to do an easy, quick, within 2 minutes, real-time review and real-time improvement. And then the other team of 3 people come to immediately have a deep shared common understanding of the design. And then when they sit down at their computers and start programming, they can just look at the wall and they have an easy, quick reference for, in this case, the physical architecture. Or if someone walks into the room and wants to see what the big physical architectural ideas are, they can just say, well, look there on the wall. Now, of course, this doesn't work at every level of team. Most of my work is large teams, 75 people, 150 people that are multi-site and distributed. And this kind of lightweight modeling technique is insufficient for large multi-site teams. But nevertheless, when we're talking about a sub-team, and there is always at some level a sub-team, at the sub-team level, this is an especially useful technique. This is a web page. And this indeed is a good way to model user interfaces. So this web page was created by these 2 women in the middle there, for example, and they spent about half an hour putting up post-it notes and little pieces of paper on the wall, and other people would come over and give feedback, and they would move things around, and other people would give their input very quickly, and thus they were able to rapidly focus on creativity and flow, and focus on the big ideas, the information content, the basic placement, rather than getting slowed down with unimportant details or using slower computer-based tools. This is a UML activity diagram created by one of the teams, not during a design day, but during a requirements workshop. Another thing that I do when I'm coaching teams through say a 3-week time-boxed iteration is that we'll typically spend 1 day in a focused requirements workshop where the programmers and domain experts get together in a face-to-face conversation, and together they do requirements analysis, which will include spending time at the whiteboards sketching activity diagrams to understand the use cases and business processes. They'll spend time with a computer hooked up to a projector and using a display, type in text together into a text-based tool like a Wiki, for example. This is a team I'm working with. This is a very large project, 175 people. And this is a company that builds printer software. A lot of the work I do is in embedded domains, embedded software domains, telephony systems, network element systems, printer software, and so forth. This is a 175-person team located in 2 cities in the U.S., and this is how we do design and architecture work for an iteration. So the teams, of course, they're in multiple locations, but at the sub-team level, sub-teams are typically 7 to 10 people. And at the sub-team level, they'll spend one day, modeling day, at the whiteboards doing lots of modeling, UML sketches of class diagrams, interaction diagrams, deployment diagrams, and so on. And then after the 5 or 7 of them have spent a lot of time together, at the whiteboard they have a deep, shared, common understanding of the design, a common conceptual model. And really, this is the most important thing about good modeling. Again, notice that they're not creating these diagrams for someone else, which is a dysfunctional waterfall idea. They're creating the diagrams for themselves to come to common understanding and to explore the big design ideas. And only after that, then after a day of that kind of modeling, they sit down at the computers like they're doing now. This is day 2 after they've done modeling day. And they start programming as a team. And they can look at the whiteboards, and of course they can use those as inspiration when they start to program. And they have this deep internal understanding of the design ideas. And of course, all of those things on the whiteboard will eventually become wrong as they start to program. Because the only truth is code. You know, diagrams don't crash. Don't misunderstand me. I'm a huge fan of modeling and of visual modeling, and I like to use the UML, but I'm not deluded into thinking that UML diagrams are the truth. UML diagrams are false. Every diagram is false if it's created before the code. The only truth is in the code. And we have to remember that. If you delude yourself with a kind of waterfall mentality, which is that you can create a design on paper and then give it to somebody, and then the code will actually reflect that design, we're just fooling ourselves. A wealth of software engineering research shows that doesn't work. And it doesn't work because we're not talking about predictable manufacturing, like the story I gave yesterday if you heard my talk on waterfall versus iterative development. This is new product development with on average 35% change and with huge amounts of unreliability in the components we use. And you may know this, software is the most complex thing that humankind creates. I remember back in 1985 there was an article in Scientific American that analyzed the degrees of freedom and the degrees of complexity in software systems as clearly orders of magnitude greater in complexity than anything else that human beings create. More complex than a nuclear power plant. I work in nuclear power plant software systems. More complex than building a space shuttle. Software is the most complex thing that humans create. And to believe in the context of that complexity and change and defective components and weak tools and frameworks and languages that change every 6 months, to believe in that context that diagrams or designs on paper will accurately reflect what's going to be in code is just a false assumption. And don't misunderstand me. I don't mean to say that what we sketch on a diagram will be completely incorrect or always incorrect. I'm speaking about averages. This is just a close-up of what's on their wall. You can see they've sketched some UML class diagrams over on the right-hand side, and on the top left corner you can see some UML communication diagrams, static views and dynamic views. And notice that the emphasis here is not on notation. It always amuses me when people go to a, quote, a UML course, because the UML is the most unimportant and trivial thing in the world. I mean, the UML is just diagramming notation. It's a box, and whether you use this kind of an icon or that kind of an icon, I mean, how trivial and unimportant is that? You know, knowing UML notation is absolutely meaningless. I sometimes visit organizations who think that by taking a course in learning UML diagramming notation, they're actually going to know how to design good software. Nonsense! You know, knowing how to design good software is infinitely different than knowing the most trivial and unimportant subject, which is UML diagramming notation, which is just a meaningless subject. So I urge everyone to pay no attention to UML notation and focus what's important, which is good software design principles, low coupling, high cohesion, design patterns. That's what it means to create good designs, not knowing whether you use UML symbol A or UML symbol B. That's meaningless. So in a good approach, these people are paying no attention to UML notation. You can see it's very sloppy and messy, and notation is essentially unimportant, and their focus is on good design ideas. Another important idea is cross-team understanding. Whenever I do a modeling day, I don't have, if it's a multi-team project, I don't have just one team in the modeling room. So for example, the team I'm working with building printer software. In one city there might be 70 or 100 people, and we'll take large numbers of those people, 50 or 70 of them, and we'll put them in giant rooms next to each other, huge spaces, you know, rooms like this for example. And we'll cover the rooms wall to wall with whiteboard material, and then, like we see here, the sub-teams will be working on walls close to each other. So those 4 people are one sub-team, and those 3 people on the right with some more people off to the end are a separate sub-team working in a different feature in a different component area. But they're close to each other, and it's a fact that these 2 components have connections. These components talk to each other in software. So what could be more sensible than having the people talk to each other when they're doing the design? So we have them stand next to each other, so this team can look at what they're sketching on their wall and vice versa. And then during modeling day they can have a deep face-to-face conversation in which they work out a lot of the connection and communication and collaboration issues through face-to-face conversation and through easy visual modeling in which they can look at each other's diagrams. And then where possible, we co-locate the teams so that the sub-teams that have dependencies on each other are physically close together. That's not always possible, but insofar as it is possible, we try to do that as well. I mentioned the idea of review, and that's very valuable during modeling days doing agile modeling. So for example, this is a team I'm working with in Finland at Nokia. Nokia has adopting Scrum and Agile methods in a huge way in their network elements division, where I've been spending a lot of my last year and a half. And giant projects, huge teams, multi-site, typically 10 to 20 million lines of C, C++ code is a typical profile of one of these projects. And this is just a shot of one sub-team of a giant project. And to tell this particular story, the 4 guys in this team, it was modeling day, and they were having to implement a particular protocol, and they were figuring out the algorithm using a UML activity diagram. And they spent about 45 minutes at the whiteboard together sketching a UML activity diagram and trying to come to an understanding of what the algorithm steps were. The lady was a subject matter expert, and she was busy with another team for about 45 minutes, but then she was freed up, and so they called her over. And then she comes over and she looks at the sketch, and within 5 minutes she identifies through a conversation with them a number of really important misunderstandings that they had. And it would have been very difficult for those misunderstandings to be revealed without this approach, using giant whiteboard spaces, modeling teams together, people having face-to-face conversations, and doing a review, not by reading a document alone, but by doing a review in a face-to-face conversation where the creators of the object and the reviewers of the object come together when the object is being created. And this is a theme of Agile modeling, is that you bring together the producer of the object and the consumer of the object and together they create that object as a collaborative effort. Requirements by collaboration and design by collaboration. So in Agile modeling, for example, we do practices like, instead of business analysts creating a requirements document in isolation and then handing it off to programmers, which is a horrible idea, instead in Agile modeling we work in requirements workshops where in a face-to-face conversation hands-on programmers come face-to-face with business analysts and domain experts, and in a common room for 1 or 2 days they write and analyze requirements as a team, bringing together the producer and consumer of the requirements. And we do that repeatedly, multiple iterations. And I've stressed this several times, another advantage of Agile modeling, in which we model in groups in big whiteboard spaces, is that the team comes to have a shared understanding. And this is so important and valuable in software design and in requirements. When programmers and domain experts come together to write the requirements, when designers, developers come together to sketch out the design ideas as a team, as a group, they come to a deep mental shared model of the design, and that's so powerful. So some of the themes of Agile modeling is to use simple tools that encourage flow and encourage collaboration, which almost always means avoiding UML case tools, focusing on giant whiteboard spaces, using marker pens, digital cameras to capture sketches, and so forth. How many of you here know about what a wiki is? See a show of hands? Okay. So if you don't know about wikis, you must learn about wikis. Wikis are hugely popular. Virtually everybody in the agile and iterative development world uses wikis. And what we do if we're concerned that the cleaning person is going to come in and wipe the walls at the end of the night, or if we need to share these sketches with another team in India or in Los Angeles, then what we'll do is we'll take digital photos of all of these pictures and we'll drop them into wiki pages. So for example, what I do when I'm coaching a team, I'll create a wiki page, for example, called Modeling Day 1 in the first iteration, Modeling Day 2 for the second iteration, and we'll just drop in snapshots, digital photos of all of our sketches, and thus they're preserved and other teams around the world can see the sketches. theme of Agile modeling is, if you are modeling alone, it's a mistake. We never model alone. We always model with at least one other person, and ideally a whole sub-team of 3 or 7 people working together in a shared conversation. And to reiterate, having multiple related groups modeling together in the same room. And another practice in Agile modeling is to do multiple related models in parallel. The most concrete example of this is to do class diagrams and interaction diagrams basically at the same time. A class diagram, like we see at the lower right, is a static view of your software. And class diagrams are somewhat useful, but class diagrams are rather weak because they leave out the important details, which is the dynamics, how the actual objects collaborate and interact. And so we see a related model, which is a dynamic model or a UML communication diagram, which is showing the dynamics of how objects are interacting in software. And that's the really important thing. If you just do class diagrams, you've missed all of the important design work. All of the hard design problems are discovered through doing communication diagrams, the dynamic diagrams. And the two views, the static view and the dynamic view, are both important to do in parallel to create these complementary views. Another practice in Agile modeling during the modeling day is show and tell, where the multiple modeling teams in the common room or the rooms that are near to each other are visiting each other's whiteboards and explaining the results to get real-time review and shared deep understanding. Now, let me go back. Let me ask you a question. Is this documentation Not at all. Any diagram created before code is bullshit. Any diagram created before code will be wrong. If you believe that some diagram created before code was created will be reliable, you don't work in the software business. Or you don't work as a hands-on programmer, because any hands-on programmer knows that the diagrams will be wrong. And then over time, the actual code, which is the only reality, the only real design, is the code. Everything else is basically just blah, blah, blah. So diagrams created before code are unreliable. If you were to, take these digital photos and then have the team program for 6 months, and then if you were to believe that these diagrams made 6 months before programming were reliable, you'll be disappointed. It won't be true. That doesn't mean these aren't valuable, but they're not documentation. They're inspiration. They're an inspiration to kickstart programming. But that doesn't mean that documentation isn't important. Please don't misunderstand me. Documentation is very important. What I mean by that is architectural documentation and design documentation. But that's a different subject, and documenting architectures is not modeling. We're talking about Agile modeling. The state of the practice on how to document architectures is called the N+1 view model, actually first described by a Frenchman named Dr. Philippe Cruschen, who's also the creator of the unified process. And the N+1 view model is widely understood to be the state of the practice in how to do good architecture documentation. And in my book, Applying UML and Patterns, I've got a whole chapter which talks about how to document architecture skillfully based upon the N+1 view model, and using another popular technique called technical memos. And I encourage you to take a look at that chapter for a solid description of how to document architectures. But question, when should you document the architecture? Actually, it's a rhetorical question because I'll answer it. You should document the architecture at the end of a project, not at the beginning. Architectural documentation looks backward at the actual code base and describes the actual code base so that it can be an accurate reflection of what the only true design is, which is the code, and then that documentation of the actual code can be a reliable learning aid for people joining the project later on. So the appropriate time to do architecture documentation, which is being used as a maintenance aid or a learning aid, is at the end of a release, not in a waterfall approach thinking before the code was created. Now, the only absolutely necessary time to do the documentation is at the end of the project as a reverse engineering description of the actual software. But it may be useful to make it earlier as well, to make a version of it earlier. For example, suppose it's a 12-month calendar time project and there's a small team of 15 people working for the first 3 months programming and stabilizing the core architecture. And then after those 3 months, 25 more people join the project in order to scale up the project to a larger team. Well, at the end of those 3 months, that would be a good time for the original team of 15 developers to get together in a documentation workshop and to spend 1 or 2 days looking backwards at the actual code they've created over the prior 3 months and to document it to create a learning aid to support the larger team coming on in the remaining iterations. So it's important to know that models are not documentation. Architectural documentation is important, but that's not the same thing as modeling. Anything we create before code is called a model, and models are inspiration, not documentation. And in Agile modeling, the mindset, the attitude is that we model to have a conversation, to group problem solve and to develop shared understanding. That's a mantra. We model to have a conversation. And every model is wrong, and that's okay. That's the attitude you should have. Every model is wrong, and that's okay, because models are not documentation. They're inspiration. The presence of them is to create a context for a conversation at the whiteboard. We model to have a conversation. Now, how do you make giant whiteboards? There's lots of options. I'll show you one that we frequently use. So you can buy this stuff. In Europe, the best version is called Magic Chart by LegoMaster. And it comes in giant rolls of like 100 meters or so. And it's a kind of plastic sheet. This is just a little sheet, but as I said, the European stuff, LegoMaster, comes in giant rolls. And it has a kind of static cling. So you see, it just clings to walls, it clings to glass, it clings to wood, to anything. And it works just like a whiteboard. You can work with it on a marker pen, you can erase it and so forth. And what you can do with this stuff, especially when you get it in the rolls, is you could take a room like this, for example, and you can just roll out and cover the walls and create giant whiteboard spaces in 2 minutes. I could turn this entire room into a whiteboard in 2 minutes. Normally I recommend two rows so that you get about a meter high of whiteboard space. And then a good rule of thumb is that for each modeling team of 3 or 4 people, each modeling team should have at least 4 or 5 meters of whiteboard space. So as a rule of thumb, for a small team, 5 meters by 1 meter of whiteboard space is more or less enough for a modeling day. So, in other words, one whiteboard is completely insufficient. We're talking about, huge, hundreds of meters of whiteboard space during modeling day. This is the most powerful thing that I can recommend to you. I've been doing this for 20 years, and I can't put it any simpler than this. There's a linear direct correlation between the number of square meters of whiteboard space and the success of your architectures and design. And I'm not joking, it's that simple. Every extra square meter of whiteboard space you give to your team, the design will get better and the software will get better. I can't think of a cheaper, simpler technique to improve design. And there's many ways to create whiteboards. I give an example there of a web page that gives like 10 different technologies and tools for creating whiteboards. And so your rooms where developers work, your programming rooms, the walls should be free. Walls are the most important part of the room for software teams. There should be no furniture against them, no tables, no paintings, and so forth. And they should be free for information radiators and lots of whiteboard space. Get rid of cube walls, get rid of separate offices, and at the sub-team level have teams work in small co-located areas. If you've got a giant open space where you used to have cube walls, then turn the cube walls into like a big walled area around a sub-team so that they can hang this stuff up on the cube walls. And during a modeling day, therefore, we'll have things like whiteboards, digital projectors, and so forth. Now, what is a UML case tool good for? It's not usually good for forward engineering, that is for creating diagrams with inspiration, but it is useful for reverse engineering. What I use a UML case tool for is before modeling day, I'll point the code base at a UML reverse engineering case tool, transform all of the code into UML diagrams, and then I'll use a big plotter typically, and I'll print out the most interesting diagrams zoomed up really big on giant plotter paper, and then I'll hang them along the top of the room in giant plotter paper sizes. And then when the teams are doing modeling day with their marker pens, they can look at those reverse engineered diagrams and sketch on top of them or be sketching on the whiteboards below. But because this tool use is very simple, you virtually need only one copy of a UML tool for every 100 developers or 200 developers, because it's only used, once every 3 weeks. So you don't need to go out and buy a lot of licenses of tools. I think I'll skip that. I'm going to wrap up with a few comments and then leave a little bit of time for a few questions. So, as I've stressed about the UML, what's important is not notation and diagramming details, but the intellectual skills of how to design low coupling, high cohesion design patterns. And the point of the UML is often obscured in case tool sales pitches, silicon snake oil like MDA, and so on and so forth. It's really very simple. That's the essence of the UML. That's its real point, is that humans are visual animals. We've got a huge amount of our brain dedicated to visual processing. And so to exploit that in big visual spaces, this takes advantage of a natural strength of humans. And that's got nothing to do with case tools. So the master said, "Luke, harmful is knowing how to read and draw UML diagrams, but not being an expert in hands-on programming and design and patterns." UML tip: the most common underused diagram are communication diagrams, like we see in the top left corner. Do less class diagrams and do more communication diagrams. Or I could generalize it and say do more dynamic modeling and yet less static modeling. Because when you do class diagrams, you miss a lot of the hard, difficult issues that have to be resolved in design. All the difficult design problems aren't in the class diagrams, they're in the dynamics of how the methods and objects interact. A few tips for hand sketching. Sketches in parallel, we've talked about that already. When you're working at a whiteboard, do not do sequence diagrams, if you know what I mean by a sequence diagram. Sequence diagrams are good for reverse engineered documentation, but they're terribly space inefficient. They chew up or they consume whiteboard space very quickly, and they're very hard to change. And when you're sketching and changing sketches, use communication diagrams, which are much more space efficient and easy to change. If you're working in a group at the whiteboard, rotate the pen. Get everyone actively involved. Don't let one person dominate. Keep your bottoms and sides open if you're sketching a class. Use simplified UML, like that's an interface, that's an abstract class. You know, don't worry about detailed notational or correct notational points. Spread elements out, give yourself lots of space. That's not important. A couple of these things are pretty small. Small point, you can't see this too well, but there's patterns, defined patterns like proxy, factory, command, processor, and this team is embedding those design pattern names in their code, essentially. And that's a good practice, because then when you read the code, you can see what design patterns are being used. That's not critical. Minor points. Okay. So there's a few tips for agile modeling. All right. Well, with that, merci beaucoup.